Hello everyone. Today we shall be going through the derivatives of inverse trigonometric functions. So we are usually normally given these equations, the derivative of arcsin x or inverse sin x or arccos x and arctan x. However, actually deriving these derivatives is important. So let's first start with arcsin x. We know that arcsin x can be written, we can write this as y equals arc sin x, and this basically gives us that x is equal to sin y, and this can be further written as, by getting the derivative with respect to x on both sides, 1 equals cos y dy by dx, and by subjecting dy by dx we get dy by dx equals 1 over cos y. Now what we want is dy by dx, however we have got it in terms of cos y, so in terms of y. So we want to get this in terms of x, so what we do is we do a small manipulation. Just consider a right angled triangle. With y being the angle, so we know that sin y is equal to x from over here. So if sin y is over x is equal to x, sin y is equal to opposite over adjacent, opposite over hypotenuse. So this is going to be equal to x, and the hypotenuse is going to be equal to 1. So that means the adjacent side is going to be equal to 1 minus x squared and the square root of that. So from this we can get an expression for cos y, which is equal to the adjacent divided by the hypotenuse. So that's going to be equal to 1 minus x squared, the square root of that, and that means dy by dx is equal to 1 over cos y, so that's equal to 1 over what we just got, 1x squared. Therefore, derivative of arc sin x to 1 over 1 minus x squared and the derivative of that. As you can see, this is exactly what we have got over here. Next, let us derive the derivative of arc cos x. So that's actually quite simple. Now that we know the derivative of arc sin x, we can write arc cos x as pi by 2 minus arc sin x. So if we get the derivative of this, we have cos x. So the derivative of a constant is 0, so we just ignore that, and then the derivative of this particular term is the negative of what we derived earlier, so that is minus 1 divided by 1 minus x squared, the square root of that. So this is the derivative of arc cos x, and you can see that is exactly what we have over here. Now let us derive the derivative of arctan x. We do that in a similar manner to how we derive the derivative of arc sin x. So we write y equals arctan x, and that basically means that tan y is equal to x. So if we get the derivative of this on both sides, we get sec squared x, sec squared y into dy by dx being equal to 1, and therefore dy by dx is equal to 1 over sec squared y. So we need to get this in terms of y. So we do a similar manipulation as before. We get down a right angle triangle, so just like that, and assume that the angle is y. We know that tan y is equal to x, and tan is basically opposite over adjacent. So the opposite is x, adjacent is 1. That means that the hypotenuse is x squared plus 1 the square root of that. So sec y is basically equal to 1 over cos y, and cos y is basically equal to 1 over x squared, square root of x squared plus 1. So therefore this is equal to 1 plus x squared. Basically we take the square root of that, and then we can basically substitute to this to give us dy by dx equals 1 over 1 plus x squared. Therefore, that means that the derivative of arctan x is equal to 1 over 1 plus x squared, and that is exactly what we have over here. I hope you understood how we derive the derivatives of these inverse trigonometric functions. And that's it for this today. If you have any questions, please feel free to post them in the comment section. Thank you.